Hello! You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
True West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
Yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady
And Levi.
and Brady too. We're the three members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes, all raps have one rhyme.
We'll see you on 2 West.
Yes, 2 West
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because moths are the
disgusting gray moths.
Yes, those gray moths that you hear, they're
Yeah.
like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all.
Hello, I hope this is working. Yes, it is. Okay. Welcome to Nerdish. I'm Levi. Brady will be here, but he's on his way. Forgivably so, but he is on his way. Okay, so doing commas today. I think that's what I called it, or something along those lines. So I forget who was asking. I think it was Robot Dancer. I'm going to just write up the four general uses of commas. As people come in, let me know if you have questions to clarify on any of them. And then we can do whatever you want. It doesn't seem like there are any questions in the... oh, maybe there is. Nope, that was it. Okay. So, we have listing commas. That's the first one. So this is lions, tigers, and bears. This is, you could be listing, let's make a bulleted list, I guess. We would do, you could list adjectives. You could list nouns. You could list phrases. You can list whatever you want, as long as you keep it consistent throughout. Okay. Then the second one is comma fanboys. So that's for, and, nor, but, or, yet, so. If you have questions about when to use that, let me know. And then number 3 is dependent clause, comma, independent clause. And then the fourth one, and if you have questions, again, same deal. And then the fourth one is non-essentials. Non-essentials, also called the positives, but unless you know that word, there's no point in learning it because it's not actually demonstrative of what the role it plays, whereas non-essentials is a better word. Okay. I should post in the Discord. I didn't do that because I was running around getting ready because I didn't have Brady to help me today, but he will post as soon as he gets here. So that's listing commas. And then the fanboys, foreign, nor, but, or, yet, so, dependent clause, and non-essentials. These will always be, I would always recommend using this order of them. It's certainly helpful. So let me show you. I'm going to pull up a test, and I'm going to pull up a reading section, actually. That's not what I wanted. Okay, fine. Yeah, I'm going to pull up a reading section. It's going to be an ACT reading section. It doesn't really matter. I'm just going to show you how many commas there are in general, and how it's really, it's always, almost always going to be one of these four. And for the purposes of this test, you can just rely on these four. I'm going to do that. All right, I'm just going to do one column. All right. Good. Okay. Let's just go to the beginning there. Okay. I'm going to make this full screen for myself so I can see it. All right. I'm going to read this, and I'm going to show you how many commas come up and how they all fit into this. And this is a really good exercise to do if you find yourself getting lost in the English section of the ACT or the writing section of the SAT. So we have, one of my best races could hardly be called a race at all. Okay, no comma there. I was a senior in high school, comma, gunning to qualify for the USA Junior Nationals, period. Okay, so that's second sentence. We have, so that first sentence, I'm going to do this in yellow. I'm just going to show parts of speech in what we talk about for the test that reflects this. So first we have an independent clause, and then we have a period, so that's fine. Then we have an independent clause, it looks like. So we have, the previous summer I had missed the, oh no, sorry. Second line, I was a senior in high school. That's an independent clause, I and was, subject, verb. I was a senior in high school, comma, gunning for the USA Junior Nationals. Well, we're not listing anything, so that's not it. It's not comma fanboys because it's comma gunning. DC comma IC, no, because we start with we start with an independent clause. So then it's got to be a non-essential, and it is, right? I was a senior in high school, and what kind of senior in high school was I? I was gunning for nationals. So we have independent clause, comma, non-essential. Let's keep going. The previous summer, I had missed the cut by less than a second in the mile. And just the day before, at my high school regional meet, oh my gosh, there are lots of commas. So, let's start over. The previous summer, I had missed the cut by less than a second in the mile, comma. That really seems like an independent clause to me because it can stand alone. We do have a subject and verb. So then we have an independent clause. Then we have a comma. What comes after this comma? Ooh. And just the day before, at my high school regional meet, I had come within 0.3 of a second. So actually, I think this is comma fanboys. Then we have the beginning of our independent clause. We don't have a subject and verb in this point, but we do have, and just the day before, I had come within 0.3 of a second. So actually, I had come within 0.3 of a second is our independent clause, pretty far away from this comma fanboys. So I'm going to say that we have a non-essential, then we have another non-essential, and I'm cut off. Good. And I'm going to abbreviate fanboys with another abbreviation for just fan, so that I save space. So we have independent clause, comma, fanboys, comma, non-essential, comma, non-essential. No. There's no comma here. Independent clause. That's what we have. We have the previous summer I had missed the cut by less than a second in the mile, comma, and just the day before, at my high school regional meet, I had come within 0.3 of a second in the 500-yard freestyle. Now we move on. We have a period here. Oh boy. The qualification time was 4:39:69. And then a semicolon. I swam 439.95. So it looks like we have an independent clause, semicolon, and then another independent clause. I'm actually pretty pumped about that. I think I'm maybe... Is anybody watching? Or are you just enjoying how maybe tedious this is? I think this is a really good demonstration of how often these come up and how useful it is to know them. Because these sentences are relatively complicated, and it's not as though when you're trying to read to understand stuff you have to use those things and know what all the commas mean. Not at all. But it really helps on the English section if you practice this on the reading section for either test. I'm going to do one more sentence. So, we have independent clauses, we have non-essentials, we have comma fanboys, we have a semicolon in there. There's no listing yet. Listing is actually not super common. It's very common on the test, but you don't list stuff all that often. Then we have the qualification. The next day, Sunday, I drove with my mother to the far side of Houston where a time trial was being held, an informal, unadvertised event. Oh my gosh, this is beautiful. Okay, so the after that, I'm really excited about this. The next day, Sunday, I drove with my mother. I'm going to call that two non-essentials. The next day, Sunday, I drove with my mom. And you could maybe say this is sort of included with your independent clause. I'm not going to say that here. If this got thrown at the end, you wouldn't need a comma, right? I drove with my mom to this other thing the next day, right? But we don't have that here. So the next day, Sunday, I drove with my mom. What do we have next here? The next day, Sunday, I drove with my mother to the far side of Houston where a time trial was being held. An informal, so then we have a dash, which offsets non-essentials. So we have a non-essential with a little non-essential. Oh no, sorry. Then we have listing. I don't know how to demonstrate that. Within our non-essential, we're going to have listing commas. And now there are only two items, right? We have informal, unadvertised event thrown together at the last minute, period. So after that dash, we have an informal whatever event. That's all a non-essential, and it is listing. So I'll actually put this listing thing here. But that's what the comma is for there. And then we finish the sentence. Okay. Everybody seems to be jumping for joy at this, which is good. Oh, cut off, whatever. So this is super useful. If you have trouble identifying commas and comma questions, you're pretty hit or miss. This is, I think, the best way to practice. I would stay away from using the literary narratives and the historical pieces that are Old Englishy, because those use commas in weird ways, and the turns of phrase they use, the idioms, they're just super confusing. This is some kid talking about swimming at nationals. Hey, Bird.
What is going on here?
Bird, we're doing commas because you weren't here.
Oh, no.
So I got very excited.
Oh. They asked for commas?
No.
Well, don't let me stop you.
No. I actually was just done. I just finished.
No way.
I don't want to go through the entire passage. Nobody said hi at all. I didn't post in Discord. Could you do that? Okay.
I can, yeah.
Thank you. Yeah, but this is what I tell kids to do, or I do with kids who have trouble identifying parts of speech and sentences and stuff.
Have you surprised how many kids have trouble identifying parts of speech and sentences?
Yes. Yeah, well, actually, I wouldn't be. I was once.
Very true.
Yes.
Very true.
But also, this is a great passage for it. I didn't quite realize. We have just an independent clause, then we have an independent clause with a non-essential. Then we have an independent clause with comma fanboys, two non-essentials, and then another independent clause. Then we have a semicolon separating them. Then we have non-essential, non-essential, independent clause, dash to offset a non-essential with listing commas in the first four sentences. You have no idea what I just said, and that's fine.
I was doing the Discord thing.
I know. No, I know.
You asked me to do it, and now you're mad at me.
I don't feel mad at you, but I guess I should be now?
Well, now that I'm raising my voice, you should be too.
Yes. Oh, I want to show you.
What?
This is what I've been working on.
Oh yeah? Show me, what is this?
Huh?
Is it a windmill?
It's not a windmill.
I mean, a wind chime?
Yes.
You made it?
Yes, did you?
Yeah, I did. Wait, what is that for?
I'll tell you later.
Hey, Waldo the Bear's here!
Hey, Waldo.
Waldo, tech bear.
Nice.
It's alright, Waldo. I'm just finishing up a protein bar. Trying to stay in shape. Waldo, how are you? Give us the Waldo update. We want to know all things Waldo. Wait, Levi, what is that for?
Yeah.
For where?
I'll tell you later.
Alright. Maybe for Nerdish?
No.
I thought we wanted to get a Nerdish wind chime.
It's much better.
Okay. Waldo, what's the update, man? Slash woman? Do we know if Waldo's a boy or girl?
No.
Very good. Okay, so Levi talked about commas. Talked about factoring yesterday, which means today
You put them together.
Oh, Waldo has been good. Very good, Waldo. Levi and I were a little worried, but now I think we'll rest easy.
Yes.
For Waldo has been good.
Yes.
For he is a bear, and bears are always
Best.
good.
Good.
Bears are best. I should have said that.
Waldo, do you have any questions about, I don't know, math or English or SAT or ACT or, I don't know, whatever what's been on your, been working a lot but still enjoying the summer. Very nice. That describes us exactly.
Well, isn't our friend Justine watching? Justine's watching.
Oh, is she?
Yes, she is.
Hi, Justine.
Hello, Justine.
How are you?
Justine, are you Waldo the bear?
I think so.
Hold on.
Wow.
Very good. No questions right now.
Okay.
Well, Waldo, let's expand it then, because it seems like it's just you, us, and our friend Justine.
Yes.
I'm not her. Yeah, okay, I assumed that. I'm a man. Justine is very much not a man.
Justine is not a man.
No.
You are the man, Waldo. 'Cause
Yeah.
You might be the only person watching us.
The
who's
only
a man.
mailman watching us.
Yes.
Yeah.
I normally watch the mailman, but now it's flipped.
Yeah, the mailman is watching you.
And I bark at him.
You bite him on the leg.
Yes.
Waldo, do you have any questions concerning anything else besides the SAT or ACT? I mean, everyone has questions.
Yeah. What has been going on for you?
Yeah.
That you've been pondering.
Don't be
Mhm.
afraid to really, give it to us straight.
Yeah.
You're not sure what your passion is. You're unsure of your direction. You're wondering what happens after you die. You're wondering where babies come from.
Yeah.
Hint, you probably should know at this point.
And that's your hint.
And that's your hint. Yes, that is all we will say. For this is a show for teenagers.
Yes.
And teenagers don't know yet.
Right.
Just like Santa Claus.
The teenager brain can't quite comprehend.
Yeah, the teenager brain doesn't have enough nutrients in it for it to be able to comprehend certain things like that.
Why
Yeah.
don't you pick something?
Why don't we just clear this off first? This will
Okay.
take us a couple minutes.
Yeah. We
Yeah.
can draw this one out.
Yeah. Oh, jeez, my hair's all a mess. Yeah, you go ahead
For
and
a
do
tutor.
that. I'm going to go ahead and apply this thing.
What is my purpose in life? Well, Waldo, that's a good question. Your purpose is kind of... I was thinking about this the other day, Bird.
Oh, were you?
I was, about Waldo's purpose.
Oh, really?
Thank you, Brady. What is your purpose? I would recommend doing a decent amount of soul searching. If you are soul searching and you don't find anything, then your purpose is probably just soul searching and not finding anything. And those are kind of the two options. Is finding something and then you'll know, or not finding it and that's what it was. That makes sense.
That's not helpful at all.
Oh. Brady, I wasn't talking to you. It actually would help Waldo a lot.
Oh, yeah?
Yes.
Very good.
That's what Waldo said. Waldo said, oh no, Waldo didn't say anything. Yeah, see, this is why we generally stick to SAT and ACT tutoring, because any other questions we can't answer.
Levi,
Yes, Bird.
I need your input.
Do you?
So let's see if Justine texted us. Did she text us? Let's see. Oh, she just said hi. Is the headband too much? You really can't see it on the stream. Maybe you can.
I mean, too much for what?
Too much for just generalness. Is it too much?
I don't think it matters for stream.
Okay, but
I
in
wouldn't
real
wear
life-
that in your class when you're teaching.
Oh my God, no. No, of course not. Did you guys own Alta Ipsum or are you just sponsored? We're just sponsored.
We're just sponsored.
Yeah. We'd like to own Alta Ipsum.
Yeah.
But until then,
But we had to let it go.
headband
We
isn't
fostered
invisible.
Alta Ipsum for a certain period of time, but Alta Ipsum outgrew its crate, and we just couldn't house it here anymore.
Yeah.
So we let it go. But we still sponsor it.
Yeah, I mean, no, yes. Yes, we sponsor Alta Ipsum. The hope here is through the actual sponsorship relationship, which is that Alta Ipsum sponsors us, we're going to get some money and eventually collect enough money to buy Alta Ipsum. And then we'll finally be sponsoring ourselves.
Right.
It'll be a closed loop.
It's the Faraday engine,
The Faraday engine.
right?
I don't know. And, I mean, he's not a bad choice to go with. He did a
Yeah.
lot of electricity and magnetism
Yeah.
stuff.
That's how you have.
Right. Faraday engine.
Yep.
It might be a thing. James Clerk Maxwell.
What?
He was he made some laws of magnetism, but Michael
Didn't
Faraday.
he and Faraday start the SAT?
No. They gave birth to the SAT.
Oh.
Yeah.
Wow.
Yeah.
Thank goodness we're doing this, because what would kids do without us?
They wouldn't know.
Actually, they do exactly the same thing.
Correct. We know what they do.
Yeah.
Yes.
What
Just
they're doing.
what they're doing, except we're not part of it. Excellent. Okay, good. We're answering the big questions right now. Answering the big questions, such as, why, when you're going to bed, do you wonder whether or not it's okay to really just go ahead and give your business partner something that he's not sure if it would be good for him, but he knows. Can you try? It's really fun to make a sentence that just keeps going. It's fun. You got to do
It
it.
was super hard to
No, dude, it's not
follow
hard.
that one.
Just go ahead and do it.
No, I thought you were saying something, and
No.
I got very confused.
No, there's absolutely nothing to say.
People always think quizzically when walking their dogs on the street side at night, because children normally stumble over their feet when they're thinking quizzically about anything on street sides, and tutors actually were spawned in Helm's Deep by Voldemort because he needed kids to not stumble while quizzically thinking. Bird.
Yeah, you finished the sentence.
Yeah, I did.
Yeah, you know what? You're talking about Helm's Deep, which makes me think about what happened shortly after. No, I'm thinking about Minas Tirith.
I only read the first two books.
Well, it's okay because you've seen the movies.
I have not.
You've seen the clips of the deleted scenes from the Return of
I've
the King.
seen only that clip.
Very good.
Yes.
Then we could probably say this in unison, but...
No, I'm not gonna-
What? Why not?
We have to tutor.
Who?
Whom?
No. Who is here for us?
Yeah, that's not what you were saying.
Stop.
Ow.
We can just beat each other up on stream, but keep saying that we don't condone violence.
We, like, literally kill ourselves. Not ourselves, but try to kill one another
Yeah.
for people's entertainment.
Yeah. Don't you? Isn't that what tutoring is all about? Is, having a tutor, tutie. Did we say tutor student? 2T is. 2D doesn't make any sense. You have to say 2T.
Yeah.
Like, she is my 2T.
Yes.
But if you say that, then you just sound weird. So you have to say student, right?
Yeah, and that's kind of... I am here, DW.
Oh, don't worry. Waldo the Bear, we know you're here. We're trying to dish it out to you. I've been distracted reading about your private tutoring. Oh, really? We do private tutoring?
We do... Do you want us to tutor you?
Yeah, because
Could
here's
we
the
tutor
thing.
you?
Here's the thing, Waldo the Bear. If you actually get us privately, then it's just one of us and you to answer your questions.
Unlike right now.
Which is unlike right now because there's two of us.
Yes, and
So,
we get very distracted.
Yes, this is not private tutoring at all. Because there's two tutors in front of you rather than one.
And it's being streamed live.
Right.
But it's honestly more likely that other people would watch this happen if we weren't streaming. Sometimes I have more people in the room when I tutor privately than I do when I stream.
I have a question for you. When we're streaming, do you ever think about the fact that students are watching us because there's a test coming up that they have to prepare for, but the test is not exactly the best gauge of what students really, really need to focus on in order to perform well in college, which is, I don't know. We're talking study skills, collaboration, and cooperation. I guess that's the same thing as collaboration, so that's redundant. Whereas the SAT is more of a collection of hard skills that you acquire by learning them in class, sure, but then also you learn them from SAT and ACT prep, which kind of comes at a later point when you should already have learned these concepts. But ultimately, you know that the sentence isn't going to end well because you've forgotten how the beginning even went. You ever think about that?
I've never thought about that.
Really?
I've never thought about what you said.
Oh, I would have assumed that you'd thought about that.
I don't think you'd ever thought about that.
Well, here's the thing.
This is dumb.
You know what's dumb? You know what's dumb?
What's dumb? Don't tell me.
All right. Then we will just stand here and wait for your questions. What if that was a Twitch stream? Just someone standing here for an hour. Yo, we gotta get to the top of the Twitch page, you know? You know how cool that would be?
Nope.
We're at the top, the people are gonna be like, what's going on here? You know, and they're gonna click on it.
Right. Okay. Yeah.
Well, what do you think about our private tutoring? Sounds like it's something for you, huh?
Would you like it? Would your parents like it? Would your children like it?
Would their parents? Would your children's parents like it?
Do you have a niece or nephew who would like tutoring?
Does this ever happen to you? You're in the car, and then suddenly you get...
I gotta head off to work, but I'll be back tomorrow with questions, I promise.
Waldo, you're our only hope. If you're gone, the ratio of tutors to students becomes undefined. You don't want that.
It's always important to divide tutors by students.
Correct.
Ow.
We're not... we don't like violence. Hey, it's all right, Waldo, we understand. I mean,
Yeah.
work. Psh, like, if you're into that sort of thing.
Do you get paid for your work?
Or do you get
'Cause that's
worked
pretty exciting.
for your paid? Very good.
Maybe what should we do?
This has never happened before.
Really?
There's literally no one watching. Oh, I work at a kid's party place. Oh, that's sick. That's you like a clown? Is it like a bouncy place where there's a bunch of trampolines, or like we talking like Chuck E. Cheeses? You know what the E stands for? The E actually stands for Ewing. E-W-I-N-G. So his name is actually Charles Ewing Cheese, but because it's his place, it's Chuck E. Cheeses.
No, it's not.
Yeah, it's Charles Ewing Cheese. So it's Chuck E. Cheeses. Do you get it?
No.
No, because that's his name. It's a bouncy place. I knew it. I love those places. They didn't really have when I was a little kid because they hadn't really invented trampolines yet.
We're kids.
Or, yeah, our kids.
Back when I was a trampoline, no kids.
You had nothing to do.
Yeah.
You were just a listless trampoline.
I had so much potential energy. Actually, not really.
No.
They don't have any potential energy.
Well, no. There's no elastic potential energy unless something's actually on
Exactly,
it.
yeah.
So you're just hanging out.
Yeah.
You have potential energy, but your potential energy is not even being realized.
Right.
How does that make you even feel?
I repressed and dissociated.
Oh, so you didn't feel anything?
Yeah.
Yeah, that makes sense.
Yep.
Yeah, anyway, Charles Ewing cheese. I don't know why I'm really kind of lingering on this, but I find it fun.
Oh, I know why.
Chuck E. Cheeses.
I get it.
Do you get it, though? The reason why I know this middle name is because my high school is named after Adlai E. Stevenson II. His middle name is E, which is short for Ewing. Hey, guys, thanks for doing my questions when I'm not here. Robot! Robot, you've just saved us with your roboticness. Robot, do you have any other questions? So we checked the Discord for questions. Did you see the questions that we did for you? Did they make sense? Did they make dollars? Did they make Chinese renminbi? Did they make Japanese yen? Did they make Swedish kroner? Did they make Thai baht? Did they make Mexican peso? Did they... Oh, jeez, I'm falling out. What else we got? Did they make British pounds?
Are you here now, Robot, and would you like us to answer more of your questions?
Hey, I wanted that. Ooh. For commas, I thought non-essentials are between two commas, but you guys put them at the beginning and end of sentences.
Non-essentials can go wherever. They're just not part of the independent clause, and
Yes.
therefore you offset them where necessary. So if we have Brady walks to school, what's going to go in here?
Albeit slowly.
We're going to go with
very slowly. Wearing purple pajamas.
wearing a onesie because of not having space.
Right.
So here's our non-essential. And this is what you're used to, right? Brady walks wearing a onesie to school.
Yay!
Put commas on either side.
But you could put that at the beginning or at the end of the sentence. A non-essential doesn't necessarily imply that it's an interrupting non-essential. This is an interrupting non-essential, but it could be an introductory non-essential or a concluding non-essential. So wearing a onesie, Brady walks to school. Brady walks to school wearing a onesie. That doesn't make sense.
You don't necessarily need one.
Well, there's a problem with that. Brady walks to school, comma, wearing a onesie. That sounds like it's the school itself that's wearing a onesie.
Not necessarily, because this is the part of speech here, because you don't have an article, doesn't make it unclear.
Oh.
Because you wouldn't say the school wearing a onesie. You would say the school that wears a onesie. Also, what's going on here is very obvious. But let's put it at the beginning. Wearing a onesie, comma, Brady walks to school.
Yes.
That's very clear. You would put a comma there. You only need commas if the sentence, if you're in the middle of it, right? If you put it at the end, so I like chocolate.
Eggs.
I like chocolate eggs.
Yes.
Um,
With my.
no.
Oh, is this the interrupter?
Yeah. I like chocolate eggs.
Albeit slowly.
No. Stop. This is why I didn't want this.
Wait, the eggs. You gotta keep
Then
the
come
eggs.
up with something legitimate.
Is it an interrupter that you want?
Yes, but
All right.
then the sentence needs to end.
Okay, so this is a concluding one.
Yes.
Okay. I like chocolate eggs, a delicacy among my people. That's fine.
Yeah.
I like chocolate eggs, a delicacy among my people. Do you like that? Delicacy among my people. I like chocolate eggs. It's a delicacy. It's a chocolate egg sandwich. I left a.
Ravenous lad. I ate 10 chocolate eggs, a delicacy among my people. So
Dude.
here we have 2 commas, but our non-essential is here, and then we have another one there. Our independent clause is right here. We have our subject We have our verb. This is our independent clause.
Although this is totally unrealistic, because even among my people, you're not supposed to eat more than 6 chocolate eggs in a day.
Yeah, keep that in mind, because that'll help you. So this is a non-essential.
I sense some sarcasm.
This is a non-essential. Nah.
Hey, Levi?
Yes, Bird.
Do you like
No.
me? What?
I know, the no was to listening to you.
You're my business partner.
I'm your business partner.
Yeah, you're my partner in business. My partner in crime.
Nope.
You know when we commit crimes?
You know what's funny?
What?
That guy who is at the front of the scandal with the
Varsity
tutoring
Blues?
stuff.
Yeah.
If he had a business partner, it would be his partner in business and his partner in crime.
That's why we need to get involved in organized crime.
So we can be partners in crime.
Yeah, and partners in business.
Right.
Or we can just make our business. Is it true that comma fanboys is equal to a period? Yes. Yes, it is. It separates two independent clauses just like a period does. The one difference is it adds a little bit more of a connection between them. So like the word but implies contradiction. So by using a comma fanboys, you're showing that two ideas contradict each other. Whereas if you just put a period, there's not a lot of contradiction there. But grammatically, they do the same thing. They both separate two independent clauses. I left a drink in the fridge. Can I go get it?
Yes.
I'm very thirsty.
Are you?
Why don't you let me get it?
Okay, so I like chocolate. Brady likes vanilla. All right, so these are both independent clauses. You could do whatever you want here. You could put a period, right? I like chocolate. Brady likes vanilla. You could put a semicolon. That is also fine. Semicolons and periods act completely the same way. And then in this case, you could do a comma fanboys, maybe do comma but. I like chocolate, but Brady likes vanilla. So yes, they work the same way as periods. I hesitate to say that they equal periods. I would think of it as there are 4 ways to separate independent clauses. You have the period and the semicolon. Then you have colons, and then comma fanboys. So comma fanboys is only used to separate two ICs. Semicolons and periods are only used to separate two ICs. And then colons are used to separate an independent clause from something it sets up. One of them can be another independent clause, and that's why we keep it as the 4 things that can separate two ICs.
Colons can also separate the small intestine from the rectum.
Thanks, Braid. That's funny. I like that a lot. Is that what it does?
I didn't know this till recently. The colon is the entire large intestine. I thought the colon was just like the end. It's the whole large intestine. It's also referred to as the colon.
Oh.
I didn't know that. Because there's the ascending colon, there's the transverse colon, and there's the descending colon. But it's all the large intestine.
Can I substitute fanboys with a period to make it seem correct? Yes. They're not going to make you choose between using a comma but here, or a period, or a semicolon.
Yeah, they can't.
They're all fine. Now, if you get 3 of these, then they're probably all wrong. You need to double check that you actually have 2 independent clauses. Maybe a comma would work because the second part's not an independent clause. Or maybe the 4th option is a colon and the second part's not an independent clause. Something like that. You'll never have to choose between these 3 used correctly because there must be something else wrong with some other punctuation, or maybe they've changed a word or 2. Not having but in here does make it wrong because then it's a comma splice. You can't have 2 ICs separated by just a comma.
Why not rectum, my lord?
Hush, Bert. What I was going to say.
You said comma but.
I know what I said.
That's what's between them.
Oh, gosh, I know, Brady. Are you done?
No, I mean, sorry, colon but. I messed that up.
Yeah, it
Comma
doesn't
but's
really
not
make
between,
sense.
right, I'm sorry. I don't really take it back, though.
Just be careful, Robot, of when you have something like, I like apples, bananas, and peaches. Because here we have comma and, but it's not comma fanboys, which should be pretty obvious from context. because it's a listing comma and it's the Oxford comma where you put it right before the last thing, and you also use an and. You do both. You don't have to worry about that. It's obviously not wrong. This is fine. They also don't test you on the Oxford comma, so you can be fine with that as well. Okay. I would say that it's time for me to erase this unless you have any questions. And we can ask more questions if you'd like as well. Okay, Bray, do you want to do some math?
Yeah.
We pull up a test or something? Do the test or something?
The one that's programmed on there?
That's not what I was thinking necessarily.
Oh, yeah,
but
a different one. You hate that test, I understand. It's just not your thing.
It's not my thing.
Right. Even though it came from your book, which is your thing.
It is literally mine
Yep,
thing.
that's your object.
It's mine thing.
Mine thing. Alright, so you want me to pull up a test, huh?
Yes.
Okay. Do you see what I see? Right, independent clause. DC, comma, I see. That's pretty good.
That is pretty good.
Yeah, but a lot of kids probably don't know that. But no, that's like a Christmas Carol. That comes out a lot.
Actually, once a year. Ooh, sorry for punching the mic for those of you who are listening.
Doesn't really hurt him that much. A song, something else, sweet as the sun.
You got what you want?
Oh, big time.
Okay.
Wait, don't leave yet.
I have left, so I can't come back.
Don't leave. What about the children?
The children will be fine with you.
Think about the
I'm
children.
thinking about not them.
Well, clearly. How can you be nearly headless like this? All right, you guys, let's get down to the. I mean, there's no one even watching, but hey, let's stop fooling around, guys. Let's get down to the big stuff, huh? Here we go. No more of this funny business. No more of this nonsense. Number 51. The list of numbers 41, 35, 30, x, y, and 15 has a median of 25. The mode of the list of numbers is 15. To the nearest whole number, how can you be nearest whole number? What is the mean of the list?
Good.
I didn't even see that one coming. Well, we're missing some numbers. We know what the median is, but we're missing some numbers. Let's write out the numbers in the order that they are in from smallest to greatest. I know we don't know two numbers. That's okay. Let's write out the other ones that we know from smallest to greatest. So we have 15. We have 30. We have 35. We have 41. And then we have x and y, and we don't know where those go. But we'll figure it out. First thing is that it has a median of 25, okay? Median is that middle number. But I usually go with imaginary numbers, but that question's got me confused. Which question? Which question are you talking about? Did you just put one on the Discord, robot? Robot?
Yes.
Oh, they did?
Yes.
Yes, all right.
Ooh, interesting.
I want to do it.
You can't.
Why? All right, hold on. Then let's block this. 1 second, robot. I must find the Discord question. All right. Ooh, I like this. I like that. All right.
What can I say except...
Your welk word. All right, we're gonna make this thing big. I like it when it's cropped. Whoa! All right. All right, I'm gonna leave up the other things in case we come back. But basically, we're trying to perform the fraction operation right there. Now, the fact that it's i's, don't let that scare you yet. Imagine that they're just like x's, all right? We're trying to subtract fractions, and whenever you're in fraction land, no matter if you have crazy denominators or not, you have to make the same denominator, okay? Otherwise, you can't add or subtract fractions. And the way that you can make the same denominator when you're using simple numbers is you can think through what is their least common multiple. So 2 and 3, if you think about the multiples of 2, you got 2, 4, 6, 8, 10, 12, on and so forth. 3, 6, 9, 12, 15, 18. The first number that they both hit is 6. So you can turn both these into 6. There is an easier way. It might not be simplified, which is okay with fractions, but if you just multiply denominators together, you will always get a number that both of the numbers go into. 2 times 3 is 6. How do we know that? Because 2 goes into 6 3 times, and 3 goes into 6 2 times, because that's what we did to find it. So when we have variables in the denominator, that is what we want to do to create a new denominator, is multiply our denominators together, and that will get us a new common denominator that we know both of them must go into, because they're both factors of this new denominator. So we have 1 over 2 plus I minus 1 over 1 plus 2I. All right, let's multiply both of these by the other denominator to get fractions that have the same denominator. So this one's going to be times 1 plus 2I. Make sure to multiply it by that on the top and bottom. Otherwise, you are illegally changing the value of a fraction. And you don't want to be caught by the fraction police for an infraction. For a fraction infraction. Yeah. Levi, I'm on fire today.
Yeah.
I am on fire. Okay. This marker, on the other hand, is really not on fire. Hold on. Okay, there we go. Let's make this look a little better. Good. Is that the same one I just used? How is that possible? Either way, now we're going to multiply. All right, 1 plus 2i times 1. That's easy. It'll just give us the same thing, which is 1 plus 2i. Oh, that's a good marker right there. All right. Now the bottom, we have to FOIL these two things. All right. So 1 times 2 gives us 2. 1 times I gives us plus I. 2i times 2 gives us plus 2i.
Why not 3 below?
Very good. And 2i times I gives us plus 2i squared. All right? And then if we go over to this fraction, same deal, 1 times this thing on the top, we get 2 plus I. The bottom we already multiplied, we're going to get the same thing. 2 plus I plus 2i plus 2i squared. Now let's pause and talk about how to simplify the bottom. So right now we have 2 plus I plus 2i plus 2i squared. One of the things, oh geez, it's right below the level of that problem. I should have seen that one coming. Whew. Don't tell my mom and dad. If you think about I just like x, you can combine these two middle terms. All right, that should be pretty straightforward. 2 plus 3i plus 2i squared. The other thing you have to think about with I, isn't it 4i? I plus 2i should only give you 3i. Where does the 4i come from? Because you can't add these two things together. 2i times 2. Hold on. Did I screw this up? 1 times 2, 1 times I, 2i times 2. Yes, you're right. Yes, you're right. Thank you, robot. That's because you're a robot, so you can do calculations very quickly. All right, I blew that one. All right, fine. Okay, that's a nice fancy 4. And then we end up getting 5i. The difference here, though, is that I squared is -1, okay? I is defined as the square root of -1. So if we square both sides, we get I squared is equal to -1 itself. So where we see I squared, we're going to replace that with -1. 2 plus 5i plus 2 times -1. This will have the effect of subtracting 2, because 2 times -1 is -2, which will cancel out with this 2 up front. So this will just be over 5i, all right? So now let's think about the numerators. So we have 1 plus 2i minus 2 plus I, all over 5i. So I'm going to rewrite that. I'm going to put that down here, actually. So we have 1 plus 2i. Now, when you're subtracting fractions and both fractions have multiple things in the numerator, make sure to put parentheses around your second and first, why not, just to be safe, numerators. Because you're going to have to distribute the subtraction. This subtraction will apply to the 2 and also the I. Don't forget that. That is a very common mistake. All right? So it's going to end up being minus 2 minus I. All right? We're subtracting both parts of this. Minus 2 minus I. And now we can look at this and combine like terms and so on and so forth. All right? Well, hold on. That's not great. Minus 2 minus I. So we have 1 minus 2, which gives us negative 1. We have 2I minus I, which is going to give us plus I over 5I. So it might be in this form. You might see it written instead as I minus 1 over 5I. But that right there should be your answer. Let me just take a look at these answers real quick. It should be over, oh, none of them are over 5I. Interesting. Why is that? Why is that? 2 plus I, 1 plus 2I. Okay, 2 plus I, 1 plus 2I. We're subtracting. So we're subtracting 2 plus I. So minus 2 minus I. We have 1 plus 2I minus 2 minus I, which would be negative 1. 2I minus I gives us just I. The bottoms, we have 2 plus I plus 4I plus 2I squared. 2 plus 5I minus 2, just 5I. Okay, okay. If we split this up, could we do that? I suppose we could, if we want to get rid of the I. Oh, that's why. Oh, they don't want i's in the denominator. I forgot about that. Just like how you don't like having square roots in the denominator, they don't like having i's in the denominator. So you do something very similar to get rid of it. It's called rationalizing. And in terms of i's, you have to do something that gets I on the bottom to turn into I squared. Because I squared is negative 1. So that'll save you. So right now we have what we ended up with, which is negative 1 plus I over 5I. If you multiply both the top and the bottom by I over I, these two i's will become I squared, which is negative 1. So this will get you out of the doghouse, so to speak. Negative 1 times I is going to be negative I. And then positive I times I will give you plus I squared. And this is all over 5I squared. So now we have some I squareds to deal with. We have negative I plus negative 1 over 5 times negative 1. Now there's negatives all over this thing. So if we just pull a negative 1 out of everything, well, let me rewrite it first before we do that. Negative I minus 1 over negative 5. Everything's divisible by negative 1. We're going to get I plus 1 over 5. Yes, that was the step that I forgot, which is rationalizing it. Or realizing it, making it real, at least on top. It's rationalized, that's what it is. And that right there should be your answer. Robot. Questions, comments, semicolons, which is like half a large intestine. Oh, that wouldn't be good. A semicolon. Wonder if there's a name for that disease. Anyway, robot, art thou still a robot?
Dancing.
Dancing. Dancing. I kind of went all over this thing, this board. Are you still here, robots? Make a beeping noise so I know you're still alive. Or whatever it is that robots are. On, perhaps? I understand. Fantastic. Levi, we got an I understand. That's the best thing in the world.
It does feel better than anything else.
Oh my gosh. Robot, any other questions? You're doing great. We're all very proud of all the robotic progress you've made. Woo, woo, woo. Okay. Very good. Very good. I post another one. Oh. Let's see what this other one is. Okay. Interesting. Okay.
Oh, okay. I got it.
All right.
Okay, thank you, Bird.
You're welcome. My pleasure.
So they're giving us. Oh my goodness, this is still.
Should I leave it this big?
Yeah, that's a good idea.
I'm kidding. That'd be weird.
They are asking us which of the following absolute value related expressions is equal to 0. So off the bat, when we're dealing with absolute value and there's a 0 involved, I would be very skeptical of anything that is absolute value of something minus something equals 0, because that's impossible. If you do the absolute value of something minus 10 is equal to 0. No, that's so
fine. It's
plus,
it's something
it's when it's
plus.
plus,
Yeah,
yes.
exactly. Oh, Robot's
So-
got a better question for you.
to a is sending 3 to 4 letters of rec too much to a college? It depends on the school. The bigger the school, the less likely they are to read all of them.
I think I sent 3.
Yeah, it depends. 3 is fine. 4 is a lot of work for them, but they'll probably read it.
You can't get hurt by that.
Yeah, I mean, go for it, but
They have to be good.
they have to be good. Yes. So, I was going to say that. Now I'm confused. Yeah, if you getting a mediocre letter of rec for that 4th one is not worth it. Okay, so in this case, let's look at B. We have the absolute value of 8 minus x plus 3. We want it to equate to 0. This is not going to work because if we subtract 3 from both sides, we get the absolute value of 8 minus x equals negative 3. This is impossible because the absolute value of anything is always going to be non-negative. That's by definition what absolute value does. It takes the magnitude of whatever's inside it. So this is impossible, meaning that B is wrong. So any of these that have pluses is wrong. And that is the whole question. So B, C, and D, they're all wrong. A, ding, 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 is your correct answer. This is a weird question because you think, okay, I have this absolute value expression, I set it equal to 0, and then I solve. But that's not the question. It's saying which of the following is equal to 0 for some value of x. They're not asking you for the value. So this is a hard one. I knew right away because I don't understand what they're asking. Yeah, so what they're asking is which of the following expressions is equal to 0 for some value of x? That is a very broad thing. So 2 minus x, is this expression equal to 0 for some value of x? Yes, it is. That value of x would be 2, right? So that would be true. This could be an answer to this question. It's a strange question. They're not asking you to evaluate any variable, x in this case. They're not asking for that. They're just asking you which of these could be equivalent to 0 given the correct x value, right? So this is not equivalent to 0 for x equals 5, but that's okay. We're just saying for some value of x. It is a strange way of wording it. So B, C, and D are wrong because it's impossible to equate it to 0. Yes, those expressions, you have a piece of it, which is the absolute value, and then you add something, and then it equals 0, which means that that absolute value had to be a negative thing, so you could add to get to 0, and that's not possible because absolute value does not give you negative numbers ever. That's that. Does that make sense? Do you have any follow-up questions on this? Dang it.
You know, Robot, this is a 3-1 split where 3 answers have something in common and one's really different. So be on the lookout for those because the one that's super different a lot of the time is right because of the reason that it's different. Very good. We have a robot watching.
What else you got, Robot?
Help us, Obi-Wan Robot. You're our only hope.
you like Star Wars?
I like it.
Yeah. Have you listened to my master song, The Great? Because he bids thee welcome.
I heard him say it. I wasn't listening at the time.
Oh.
I was texting while he was talking to me.
Well, you should have.
Okay.
You had some messages, man. Oh, friends. Pending. Oh. Who do you want to accept here?
Nobody.
Nobody.
It's fine.
Is it though?
For letters of rec, how would a supervisor for volunteering send it, and can I see it?
There's a form that, okay, you got to go on the college's website because there's a specific form that the college wants them to fill out. They can write one recommendation letter and then like attach it to these college forms. But you're going to want to find what that form, where it is, number one, and like exactly what it asks. But you know, it doesn't really. It's not like a college essay. Like these people know what a letter of recommendation is. They extol your virtues and they try to venerate you. I'm just using vocab words. They will say what they think is great about your character and things like that. And they'll say something like, "I highly recommend this person be accepted to blank," and then here's why. So generally, you don't see it. They'll show it to you if they want to, but they have a way of sending it from their side of things through your through the college's website. They either send it through the website or they mail it to the school. But either way, I'd say it's generally the case that you won't see it, unless they ask you if you'd like to. But that's between you and the supervisor. My master saw on the great bids thee welcome.
Good.
Had to cover that. Any other questions, Robot? I can go back to that ACT thing.
I just got an email from Spectrum saying, "Hey, do you want mobile?"
No.
No, I shouldn't get my phone service connected to Spectrum too.
Don't do that.
Oh.
Do not do that. Macho, macho man. I want to be a macho. I want to be a macho, macho bird. I want to be a macho bird. Someday. Definitely not a macho bird now. All right, in that case, I will bring back up the that problem I was doing before.
Oh, did I erase that word? Sorry.
No, I did.
I'm
I
sorry.
didn't think I was going to be getting back to it. Does that mean that they have to individually send it to the college? Because I want them to send one letter to like 5+ colleges. It depends, honestly, Levi. I'm not sure if I know the answer to this.
I haven't looked at
Are
rec stuff.
yeah? Are you on the use? Is it through the Common App? If it's through the Common App, it probably works for all of them. Like, go to the college's website and see how it works. We don't know. We don't know. It's probably very similar for each of the colleges. I don't know if they'd have to individually send it to each college, but also they're not going to mail these things in. Nobody mails things anymore. It's just going to be as easy as going onto a certain website, saying, "Hey, this recommendation letter is for this student," and then it's attaching a Word document and pressing send. So like it'll take them 5 minutes to send it to 5 colleges, and if they like you, they'll be okay with that. If they have a problem with that, then maybe they're not the right person to ask for a recommendation. That's my 3 cents. Okay. Oh, geez, that's not what I want. All right. Here we go. Okay. All right, so where we were, a list of 5 numbers. We have 15, 30, 35, and 41, and some 2 numbers x and y which we don't know. The median of this list is 25. Now remember, the median is the middle number when you line up all the numbers from smallest to greatest. But if you have an even number of numbers, you're going to keep knocking off numbers from the top and bottom until you get to 2 numbers in the middle. And you can't just knock those off because then you've got no middle. So what you do is you take the mean of 2 middle numbers. Okay, so one of these numbers is going to have to, because we don't see our 25 here, nor would we see it in general because these is an even number of numbers. All right. We'll take a look at the other thing we have here. The mode of the list of numbers is 15. That's a little more instant action oriented. Okay. The mode of a list of numbers is the one you see most frequently. So we only have one 15. So if 15 is going to be the mode, we need to have at least one more 15. So one of these has to be 15 for the mode to be 15. So I'm going to cross out y. That is going to now be referred to as 15. So then the question is, what is the value of x? And when we find that, we'll be able to figure out what the mean of the list is. Okay? We have to figure out where to put x. We have a median of 25. All right? So 25 could not fall between 30 and 35. Obviously, it can't fall between 15 and... It can fall between 15 and 30. It's going to go somewhere in there. All right? Now, would 15 and 30 make sense as the middle two numbers? If they were, we would take the mean of both of those, and we'd end up getting 22.5, which is not the median that we want. So therefore, x has to go somewhere in there to fix up that situation. So we're going to have 15, 15, and then x, and then 30. Where did I put my rags? My rags are gone. I will grab these rags. My rags are now here. 15, 15, x, 30, 35, 41. So what does x have to be for our median to be 25? Well, it has to average with 30 to make 25. X has to be 20. 20 plus 30 have an average of 25. So now we have our list. We got 15, 15, 20, and 30. And now it is as easy as what is the mean of the list. So remember, when you have a mean, you're adding up all the numbers, and you are dividing by the number of numbers, which in this case is 6. So we have 30 plus 50 plus 76. All of that will be divided by 6. That's 80 plus 76, which is 156, divided by 6. These things are all even. So we have 75 plus 3 is 78, divided by 3. Are these divisible by? Yes, they are. This is going to give us 26. 26 will be the mean of this list if I have this correct. 60 plus 18. Yes, 26. Very good, which is C. Okay. So that one, we might have seen stuff like that before. 52 is some high-level quadratic business. You're given the following system of equations: y equals x squared, rx plus sy is equal to t, where r, s, and t are integers. That's helpful. They're whole numbers. For which of the following will there be more than one xy solution with real number coordinates for the system? Okay. So we have a system of equations, all right? With systems of equations, most of the ones you've dealt with are probably just linear equations. And so you either use substitution or elimination, and you have a good time, and you end up figuring the point that they connect at, that they intersect at. But here we have a quadratic and a linear. So this is not going to be, you can't use elimination. You're going to have to just rely on substitution. That's the only thing you have that'll work in all scenarios. So y is equal to x squared, and the other thing we have is rx plus sy is equal to t. Levi, I'm starting this new thing where, actually, I guess I'm not. I'm starting to curl my y's. I didn't curl at that time, though, so I guess I really can't say anything about that. All right, so substitution here.
Great.
We know what y is. It's x squared. Because this is already solved for y, let's take x squared and let's substitute it in for where y is over in this equation. We rewrite this. We get rx plus s times x squared is equal to t. Okay. Now rs and t are constants. They're numbers. All right. X is the variable here. So this is a quadratic. We just happen to have constant coefficients that are all variable letters, kind of. So, but we want to solve it the same exact way as a normal quadratic, which means your first thing you have to do, get everything on the same side. So I have to get t over to the same side. This is putting it in standard form. Sx squared plus rx minus t is equal to 0. Now it's in standard form. Can you guys go over the concept of angles? Yes, we can. I'm almost done with this, and then we will. Do you have a specific question about angles, or just angles all situations dealing with angles, how they work, what they are, what they can do for you, that kind of thing. Let us know if there's anything specific. Oh, you're going to find it. Awesome. Okay, so for which of the following will there be more than one xy solution with real number coordinates for the system? If you're solving for systems of a quadratic, there are three options for things that could happen. Number one, there could be no solutions. Okay, remember, a quadratic defines a parabola. The solutions are where the parabola crosses the axis. All right, so you could have no solutions, which looks like this. The parabola never intersects the x-axis. You could have one solution where, bam, it touches the x-axis in one place, which is the vertex. You could also have two solutions where it crosses the x-axis in two different places. All right. This one wants to have more than one solution, which means it has to have two solutions. That's what they're asking, is which values, what do we need from r, s, and t in order to have two solutions? So that relies on what's called a discriminant. So if you look at the quadratic formula, the thing that gets you less than one solution or zero solution, whatever, is because you're going to end up with complex imaginary solutions. They're technically complex because they have an imaginary component, but usually you hear about them as imaginary solutions. You get a combination of like, there's no real solution, so there's two imaginary solutions for this. There's two real solutions, but they just happen to be the same number for this. But in this case, we have two real solutions. The reason why we get imaginary numbers in this case is because we're taking the square root of something. If that ends up being negative, then we end up with non-real answers. That's what gives us our no solutions deal. So the thing underneath the square root is called the discriminant, b squared minus 4ac. And this thing here will tell you how many solutions there will be. Because if it's positive, then you can take the square root and it'll be fine. And that means there's going to be two solutions. If it's equal to 0, the square root of that is 0. So adding or subtracting 0 won't do anything different. I'll give you one solution. And then if it is less than 0, that will give you 0 solutions. In this case, they want two solutions. We want the value of our discriminant to be greater than 0. So now we have to be very clear with what each of our letters is in this standard form. Our a value is what's in front of the x squared, which is s. Our b value is the coefficient of the x term, which in this case is r. And our c value is the constant at the end, which right here is negative t. So we have to plug that into our discriminant equation. So we have b squared minus 4ac, which is going to be r squared minus 4 times s times negative t. And if we want there to be more than one solution, this has to be greater than 0. A little bit of manipulation. We have this right here. And that right there needs to be greater than 0. So the answer to this is going to be f, r squared plus 4rt, 4st. I take that back. It's kind of far away. I believe it is, I gotta zoom in here. Let's see, r squared plus 4st. Yeah, it is f. R squared plus 4st is greater than 0. Let's see if Robot is posted in the Discord.
I haven't seen anything yet.
Very good. Very good. For my question, I thought that the other half of angle B would be 180 minus 40. I understand the question about the concept of like supplementing angles and adding to try to find another angle. Oh, that is a very good thing to talk about. So Levi, has Robot posted the question?
No.
Not yet?
No.
Okay. Well, we can talk about what you're asking. I'll put this on Discord for right now.
Oh, there it is.
There it is. Fantastic. Just call me. Okay. All right. In the figure above, point D is on line AC. I'll make this big.
Why don't you Make it a little bit smaller and I can draw it for you.
Okay.
Or cut off the triangle, and then I'll draw the triangle underneath.
Let me make this a little smaller. There we go. So, okay. No, don't worry. It's fine that it's messy. I just want to make sure that you labeled everything that's not obvious. So they say point D is on AC. That's obvious. We're good. AB is equal to BD is equal to CD. And I see that you put some little hash marks there to mark them all as congruent, which is awesome. That's exactly what you want to do. Nice job. And AD is 15. What is the measure in degrees of angle BCD? Right there. BCD. Disregard the degree symbol. All right, so we know 20 degrees right there. Okay. So the fact that we have all these congruent sides is super helpful.
What are we looking for? BCD?
BCD, yeah. If a triangle has two congruent sides, then we call it isosceles. So this first triangle here, ABD, is isosceles. It might be equilateral. We just don't know about this third side. So what we're about to do is totally fine. All right. This is isosceles at the very least. If you have two equal sides, they will be opposite two equal angles. So this angle and this angle have to be the same. This 20 and this one right here, because this triangle here is isosceles. So we can label this as 20. All right. Every triangle has to add up to 180. So up here, it looks like, yeah, so far you're good. You put a 20 there. Here's a 140 right here. Okay, good. This thing here is 160, so far you're doing great. Here's the thing. Okay, so you thought the other half of B would be 180 minus 40. B does not make a straight line. Only angles that make a straight line when you put them together, those would add up to 180. This angle here, A, and this angle here, B, would make 180. There is no straight line around B. B is not a right angle or a straight line, so you can't assume anything about B that the angles add up to 180. All right, you're thinking of supplementary angles, but supplementary angles add up to a straight line. We call them a linear pair, and that's the confusion that you had here. You want to keep going with this 160, because this long, thin triangle is also isosceles. So for the same reason as this other one, this angle here and this angle here have to be the same, because they're opposite two congruent side lengths. So if they're the same, and everything adds up to 180, we already have 160 taken care of in this triangle, so we only have 20 degrees left to split between these two angles. So both of them have to be 10. Robot. Does that make sense? Does that make sense? Yes, we don't have supplementary angles at angle B. As it turns out, this angle together with this other one ends up being 150, but there's no way we could have known that. There's no way. Yes, are there any other angle concepts? Well, of course there are. There are so many angle concepts. One way to remember supplementary and complementary, actually this was Brendan, who is an old member of Nerdish. Supplementary angles and complementary angles. With supplementary angles, they will add up to 180. So S turns into 180. Complementary angles turn into 90. So supplementary angles add up to 180, and complementary angles add up to 90. So that's kind of fun. Okay. I mean, there's a lot of angle concepts to talk about. I mean, parallel lines, that's a big thing. Complementary means two angles add up to 90, all right? So if we know that this is a right angle, A and B together make up a right angle. So we call them complementary. They add up to 90. They don't have to be next to each other. In this case, it's far easier if they are next to each other. But if their two measures add up to 90, they're complementary. If they add up to 180, they are supplementary. So if we have parallel lines, and so these two are parallel, and you draw what's called a transversal, which is a line that goes through both parallel lines. You create a bunch of congruent angles. All right. Okay. Another angle concept for you to know is, let's say this right here is 130. All right. The one right next to 130, these two make a line together. So these two have to add up to 180. For complementary, is it always a given that it's a right angle? Well, complementary means they add up to 90 degrees. They don't have to be next to each other. If they are, it's obvious that they add up to 90, but I'll give you an example right here of when supplementary angles actually aren't next to each other. All right, but these are good questions. What's next to 130 would have to be 50 because they're a linear pair. That's got to be 50, all right? And then if you have one intersection of lines, this angle here will match the angle directly opposite it. These are called vertical angles. 130, you see how they're definitely the same size as each other? That also has to be 130, which means this thing here has to be 50. All right? So what do we do with this down here? Think about it from the perspective of the transversal. If you're like a little guy traveling here. All right, so let's say that you're a little point and you're traveling this way. All right? You come across this line and you cross it. Then you come across this line and then you cross it. You're going to be experiencing some severe deja vu. So you're crossing this line, you see the angle that you make with it, and then you come across seemingly an identical line because the angles are all going to be exactly the same. Because these two lines are like twins. Levi, you want to hear a good joke?
Yes.
Parallel lines have a lot in common. It's a shame they never meet.
Nice.
I didn't make it up.
Are you sure?
Yeah. So therefore, for parallel lines, as long as you know they're parallel, these angles will form the same exact angles down here. So the big one's going to be 130, this will be 50, this will be 130, and this will be 50 right there. Okay? So let's take a look at like this 130 and this 50 right here. Together, they make up a straight line. Therefore, they're supplementary. They have to add up to 180. Okay? But we've got a lot of congruent angles here. So one of the things that you can look at is this right here and this right here. We call these same side interior angles. There's a bunch of different vocab for like which angles you're asking about. Like these two are corresponding. This 130, this 130. 130 and 130, these are alternate interior angles, all that stuff. But anyway, this angle and this angle here, they add up to 180. So although they're not next to each other, they are supplementary because they would hypothetically add up to 180. I mean, they do. They'd hypothetically make a straight line if you put them together. All right? So two things that make up 90 degrees, they don't have to be next to each other, but if we know that they add up to 90, then they're definitely going to be complementary. An example of that would be if you have a right triangle. And you've got that angle right there. Let's call this angle X and this angle Y, okay? We don't know what either of them are, but we know that 90 degrees is already taken care of by this right angle. And a triangle has to add up to 180. So if 90 degrees is already taken care of, we have one more 90 degrees to go before we hit 180. So these two angles together must give us that. If we have X plus Y plus 90 is equal to 180, and we know that we already have 90 taken care of, X plus Y has to equal 90. So these two right here are complementary because they add up to 90. Even though they're not next to each other, they're complementary because they add up to 90. Robot, how is this going into your processors? Are you converting this to short-term memory to be converted later into long-term memory while you're blissfully asleep? Because that's how your brain works. That's how your brain works. Do you like this, robot? I hope you like it. I understand. Sometimes the SAT has questions that add triangles in the parallel lines. Yeah. Yes, it does. Typically with questions like that, where you have to go angle hunting, you have to like find some eventual angle, don't fixate on the eventual angle you have to find. Look at what they give you and start filling in missing angle values. It's going to be a game of like jumping around, trying to find things that you can prove, and then eventually the path will unveil itself towards your final angle. But there's a couple things that you can use, such as triangles always add up to 180 if you add up all the interior angles. Lines always have to add up to 180 when you look at the two angles that add to them. Parallel lines, that kind of deal. It's usually those concepts
that carry you through those kinds of angle hunting problems. Just take little bites out at a time, and then by the end of it, you'll have eaten the entire thing without even realizing it. You know? Levi, please come up here.
Yes.
I'm scared. What time is it?
22. Wow, I stood up too fast. Did you stand
sometimes.
too fast?
22. Oh, we're almost done.
Yeah.
Wow, time. Oh! Robot put an example in the Discord. I'll pull it up for you.
Very good. I'm gonna erase this.
Oh. Uh-oh. Oh, you're doing similar triangle stuff. I envy you. No, I don't. Okay.
Okay, we got another triangle problem.
You want to draw this out?
Chesky, what's up? How are you? Or Chess Sky?
Actually, this is pretty good. All right, I'm going to make this big for you, and then...
Thanks.
There we go. Very good, Leeward. Very good.
Chesky, how are you? Or Chess Sky? Or Chess Sky? Whatever.
Oh,
Whatever
chess guy.
What do we call you?
Actually, I will draw this out for you,
Oh, will you?
because it's probably good to draw on this thing. Yes, I'll put it over here.
Can you put it over here, actually?
Yes.
Thank you. Okay, so we got this thing. Brady's going to draw it. I'm good, thanks. How are you? We're good. I think we're both tired, right, Bird?
Yeah.
I'm very tired. You're very tired. We're basically the same bird.
Cool.
All right. So we got this thing, figure not drawn to scale. I can't read that at all. In the figure above, triangle ABC is congruent to FDC. Okay, I'm going to write that down. So triangle ABC, ABC, EDC.
Yeah.
ABC is congruent, sorry, not congruent, similar to triangle EDC.
One thing quickly before I go, Robot, they never say these are parallel lines. There might be a way to prove that they are, but we don't know that for sure. So you can't ever assume something just by how it looks. All right.
Yes. Okay. So which of the following must be true if these are similar triangles? Well, what do you need for similar triangles? For similar triangles, you know that this means that all three corresponding angles are congruent. So what that means is, I'm not sure, did you and Brady just talk about, whoa. Oh, I see. So three corresponding angles are congruent. So in these two triangles, A, B, C, and these the way this is written is very important. A corresponds with E, B corresponds with D, and C corresponds with C. That's very important. Very, very important. So that let's start with C. We know that angle C and angle C correspond to each other, but also they're vertical angles. If you ever have two lines that go like this, I think Brady may have talked about this, those two angles, we are parallel lines. Thank you, Robot. I will take that as a deep, deep compliment. So vertical angles are congruent, right? As you change one of these lines, it doesn't really matter. This angle and this angle are congruent. Also, this one and this one are congruent to each other, not to the other two, necessarily. That means that we know these two angles have to be the same, right? Because they're vertical angles, but also because they correspond here. The other pairs of angles also act the same way. So let's go back to A and E. We now know that A and E have to be congruent angles. That is the definition of similar triangles. When the corresponding angles in this little guy right here are equivalent. So A and E, that means that that angle is congruent to that angle. If that's too small, let me know. And then same thing with B and D. So now that we have this, what Brady just talked about, and I'm sorry I wasn't paying the closest attention I've ever paid to what he was saying before. But he was saying that if you have two parallel lines crossed by a transversal, then the alternate interior angles are congruent, right? But if you have the same type of setup and you have alternate interior angles are congruent, it can go back the other way and prove that you have two parallel lines, which means that this line, I'm not sure what line this is. Oh, AB. I would say that this line, let's do blue, I guess. This line here is parallel to this line here because angle B and angle D are congruent, or because angle A and angle E are congruent. The angle C doesn't actually help you at all. So AB is parallel to DE. I honestly can't see that. AB parallel to DE. So answer choice C. You understand? Great. So it can go either way. With these angle problems, triangle problems, these type of things where they give you figures, draw what you did before where you were labeling everything on the figure. That's a great idea. Also, there aren't actually all that many things to memorize. There's similar triangles, right? And what you have to, you know that the angles are going to be equivalent to the corresponding ones. You know that the side lengths for similar triangles will have some sort of scale to them, so you multiply by 2 to get to the bigger triangle or something like that. And then you have complementary, supplementary. You have the interior angles of a triangle add up to 180 degrees, and then every side you add, so a quadrilateral adds up to 360, and then so on and so forth. You add 180 degrees as you add sides for the sum of the interior angles. There's a formula for that. You don't have to know it, but it's n minus 2 quantity times 180. Then, there's just not too much stuff. And then obviously area of different polygons, things like that. But when you get angles things, just start filling in angles from the rules that you know. And there aren't actually too many. You don't have to know exactly where to go. You just work with what they've given you and fill in everything and just throw the math that seems to make sense at it, and maybe you'll see where to go eventually. Okay, it is 7:30 now, so we're going to head out. Do you have any other questions, last minute things, or do you think you'll be able to have some questions tomorrow if you want to, if you're going to work more on this and maybe come back with similar type questions, or if you are looking to do other things? Yeah, no problem, Robot. Come on back whenever you can. Robot, are you in a different time zone? We're East Coast. Are you East Coast as well? I have it in my head that you're not, and that it's very late where you are, but I'm possibly totally wrong. Also, you don't have to answer that necessarily. That's also cool. Okay, it is... No, you live in NYC. Oh, wow. That is exactly the same time zone then. Hot today. Speaking of weather. Whether or not, here I come or not, I'm gonna find you and make you go. You are acting like a bird.
Not really.
Sort of.
It's a basement, so it's naturally cool. Also because we're in it. Two cool guys tutoring for the ACT. All right, we'll see you guys tomorrow.
Have a lovely night.
It's
raining now?
Nerdish. Bum ba da dum bum bum.